Scott Pace, as I think most of you know, is Executive Director of the recently reestablished National Space Council and was formerly the Director of the Space Policy Institute at George Washington University. Scott's a graduate of Harvey Mudd College in California with advanced degrees from MIT and the Rand Graduate Institute. Scott is probably the country's most knowledgeable and experienced person as it relates to both domestic and international space policy, having spent time at RAND, the Office of Science and Technology Policy, the Department of Commerce, and NASA. And he is also a fellow of AIAA. And as I think most of you heard at lunch, Charlie Trimble, our first recipient of the Space Commerce Lectureship Award, is a graduate of Caltech. Charlie went to work after obtaining 2 degrees from Caltech for Hewlett-Packard in California, and of course founded Trimble Navigation 40 years ago this fall. Among many other honors, Charlie is a fellow of the Institute of Navigation. To paraphrase a famous quote attributed to President Kennedy, I think this is the most experienced and knowledgeable assembly of global navigation experts since Prince Henry the Navigator of Portugal appeared on a stage in the mid-1400s. Before turning it over first to Brad to talk about his work with GPS and his interactions with Charlie, and then to do the same thing with Scott, I'd like to just add a little bit of additional information to where things stand today, some 40 years after Charlie, with tremendous support from Brad and Scott over the years, started the GPS revolution. So where we are today was, I think, first of all, we all know space systems and related technology benefit human life on Earth in many ways. Global communications, instantly available, accurate and timely weather forecasting, many areas of national defense and international security, various fields of scientific advancement, and of course all the inspiration that goes along with human space flight, and others. While these areas have created tremendous economic value and social benefits, they are usually delivered to our citizens somewhat indirectly. In other words, I don't know about you, but I don't directly receive downlinks from weather satellites. I tune in to the Weather Channel, and that's how I benefit from weather information. And the same thing is true, generally speaking, for most of these other areas, with one very important exception, and that is satellite-based navigation, positioning, and timing. This is an area that beginning with GPS and now supplemented by, I think, 5 other national satellite navigation systems that operate either globally or regionally, that has also generated enormous economic and societal value. But unlike the others, this is an area where most of the related services are delivered directly and personally. They show up in devices that we all carry around in our pockets, in our tablet computers, in our automobiles, and if we're in some specialized areas in a variety of other settings. And it's actually quite remarkable to take stock of what GPS and the related satellite navigation systems that Charlie and his team first had the vision for in terms of the economic engine that they have created that's running at full speed today. According to the European Satellite Navigation Agency, at the end of last year, there were 5.8 satellite-enabled or satellite navigation-enabled devices in use at the end of 2018. 5.8 billion. Now, over 80% of those were embedded in smartphones and similar devices, with about a little less than 20% in standalone units. The revenue last year from the sales of those devices exceeded $55 billion. And we add to that, while there are no direct revenues that the services generate, since GPS and the other national systems are government-owned networks that broadcast their signals at no cost, the value-added services that enable satellite navigation and timing are estimated to have been an even bigger economic engine last year, over $80 billion of indirect revenue. So altogether, satellite-based positioning, navigation, and timing products and services generated almost $140 billion in total revenue in 2017, accounting for about 45% of the Space Foundation's estimate of a little over $300 billion in global commercial space activity. To put this number in perspective, because it's so big, it's almost hard to imagine. It's about 3 times bigger than the combined global revenues that derive from manufacturing and launching satellites and rockets. It's 7 times NASA's annual budget. So the economic impact of global satellite navigation systems is really huge. And we are really lucky today to have Charlie and his 2 colleagues here to tell us how this has happened over the last 4 decades, because it really represents, I think, the most pervasive and the most personal applications of space technology that we've created. So with that, I'd like to turn the podium over to Brad, maybe to talk a little bit about his work with Charlie and some of the early technical and programmatic aspects of the GPS system that have allowed these many non-governmental applications to flourish. Brad?
Yeah. Thank you. Everyone hear me all right? The microphone's working? Well, good afternoon. It's a great pleasure to be here in a Charlie Trimble celebration. Thanks for inviting me. I've known Charlie for 36 years. For about 15 years, we would get together on Sunday mornings and talk about Trimble and GPS and business and many other things. These were great experiences. It was sort of like golf for engineers, if you get that. David Thompson has shown great vision in establishing this new award. The commercialization of space has been steadily increasing over the last 10 years. Thank you, David, for doing that. David has asked me to fill in a little about the early days of GPS. I'm going to try to do that very briefly, but I want to relate some of those early experiences to the opportunities and successes of Trimble navigation and Charlie. Now, let's see if this works. Okay. So in August of 1973, I failed. I'd gone to the Pentagon and tried to gain approval for a full-scale demonstration of a new space-based navigation system. After failing, I was encouraged by the number 3 man in the Pentagon, that was Dr. Mel Curry, to try again. So I resolved to modify the system design, and I called a meeting 2,500 miles away from my home base To avoid any resistance to new ideas, we needed a clean sheet of paper, but we had to use some of the knowledge that we already had. And we held that meeting in that Pentagon-shaped building called the Pentagon over Labor Day weekend, and I call that the Lonely Halls meeting, because if you wander around the Pentagon on Labor Day or any time on that weekend, it is darkened halls and none of the scurry that you normally see. And my purpose was to select a navigation system architecture that combined the best knowledge we had at that time. The only attendees at the meeting were about 10 young Air Force officers and engineers. They were from my program office and then a couple of Aerospace Corporation engineers. My original deputy, shown here, Steve Gilbert, was an insightful contributor to the discussions, and two of the officers, Major Gaylord Green and Mel Birnbaum. Anyone who was in Phase 1 knows those names. They were particularly essential contributors to our decisions, and we converged on the most challenging of 12 alternatives that had been studied earlier by an Aerospace Corporation team, Woodford and Nakamura. We picked the hardest one because it was also the most capable. It was three-dimensional, 24/7, worldwide. So I spent the next 3 months selling the new system, particularly to people who epitomized the resistance to new ideas and could potentially veto the program. So it was designed over that Labor Day meeting, and from the start, there was a civilian at-risk capability. I announced that to Congress when I testified in 1975, that there was going to be a civil signal available. I gained approval for that demonstration about 3 months after the failure in December of '73, and I got formal written approval in January of '74. I was the program director, and we launched the first satellite in February of 1978, a relatively short time for a satellite that had never been prototyped before. All of our testings confirmed the claims that we had been making: better than 10-meter global accuracy in 3 dimensions, as well as very accurate time. So after the testing had proven that it worked, we had the following reaction from the United States Air Force. They tried to kill the whole program. Their excuse was sort of like, why the heck do we need another darned navigator? Well, that attitude persisted for about 10 years, and then we held a Middle East war, sometimes called Iraq I, which clearly answered the question, and that famous left hook by Schwarzkopf clearly showed why GPS was so essential. There were 2 critical events that accelerated civil use and Trimble's success. The first was triggered, if you recall, by the Soviet destruction of a Korean airliner in September of 1983 over the Sea of Japan. That was attributed to a navigation error. So President Reagan announced in September of '83 that GPS would be made available for worldwide use free of charge in order to avoid such problems in the future. I had made clear 10 years earlier, civil signals were there, but they were at risk. So civilians were already beginning to experiment with them, but Reagan's decree was a guarantee of worldwide civil availability. There was a second real enabler. Back in that period, the United States Air Force would deliberately wiggle the civil signals in such a way that the accuracy was on the order of 100 meters. And that, it turned out, persisted for some time. I developed a presentation that carefully explained to the Air Force. By that time, I was retired. I went back and I carefully explained that if you put a calibrating receiver anywhere and broadcast to all the users around those corrections, that any wiggling they did was going to be totally canceled. As a matter of fact, the natural errors would also be canceled. So if you hasten that, what you were hastening is the distribution to civilians of an accuracy better than the military had. And I tried to explain that logic, and I talked to a General Myers, who later became chairman of the Joint Chiefs, and he looked at me and he said, "Brad, I completely understand, but I don't think I have the authority to stop doing that." Well, fortunately, President Clinton finally said, "We're going to turn that off." He recognized the futility. And this is a chart. I don't know if you can read the scale on the side, but it goes from 0 to about 150 meters. And the squiggly lines in the beginning are the bad old perturbed raw signal. And then you can see what happened. This was recorded during the particular period when that was actually turned off. You can see suddenly the error sucking down to about 1/10 of the value. And furthermore, they're very smooth, which means that a differential correction will persist and be good for a long period of time. So this kind of changed the game. And by 2000, GPS was not only guaranteed to the world, the full accuracy was also going to be made available. Now, between those two events, GPS had been declared operational in 1995. And the reason it was delayed is you needed 24 satellites. And Charlie has already alluded to the fact that in the early days, we had a block of 6 to 12 satellites, and they would kind of converge over a fixed place on the Earth. And if you were underneath that area for 4, 6, 8 hours, you could navigate just fine. But if you weren't, there was a problem. And it turns out Charlie discovered the key to achieving a market, a very special market that nonetheless allowed you to proceed with that. And I have to give him full credit for that. So here's Charlie. We're here to celebrate his accomplishments. He founded the most successful company ever based on satellite navigation. When I first started involvement with him, his annual sales were $1.8 million. Today, Trimble is $2.7 billion, a growth of 1,500 times. It's branched out into many areas that were not foreseen in the beginning, as Charlie alluded. Charlie laid the foundation for this remarkable record, in my opinion. That's 23% annual compounded growth over 35 years. That is a pretty phenomenal record for any company. The attributes that I think Charlie epitomizes, he's indomitable. He won't quit. Very creative, new solutions, innovative ways to think. He adapts to the environment that he finds himself in. He's very visionary. He's thoughtful. He looks a long way ahead. And I would summarize that with something that I personally use as an analog, maze bright. I liken life to a maze that you're running through, and you don't know where all the various corridors and turns might go. A person who is skilled in life somehow figures all that out, figures out which way they have to go to survive, to succeed, to grow, all the things that you set as your personal goals. Charlie is definitely maze bright. So how did he make a successful business out of a system that was not even declared operational? And to understand the answer to that, we have to look a little bit at the accuracy today. GPS accuracies, and again, there are over 5 billion receivers out there. I think that's more than one per person. A lot of us must have 2 or more. A general user gets about 2.7 meters. That's the signal in space accuracy. And when we say 95th percentile, that means that only 5% of the cases, 1 in 20, is the accuracy worse than that. And that is just the raw kind of answer you get. Now, if you go to differential GPS, which is prevalent, and you've probably been using it and not even realized it, there are corrections made to that signal that tweak it a little bit. In the case of the FAA, they have a system that provides those corrections. It doesn't improve accuracy so much, but it really improves integrity, and that's what you need for aviation. You need to know if it says this, that that's the real answer. The second sort of way we can do it was also alluded to by Charlie, and that is real-time kinematic. This is the technique that goes down to carrier waves that are about that long, 19 centimeters, and measure a fraction of that. Deriving its accuracy from that gives you the ability to control farm tractors on a rough field, bulldozers, and many other things that otherwise would be denied. Those corrections are now available virtually worldwide for a lot of technical reasons I won't go into. And then the last technique is the technique that tends to be static and provides you accuracies that are sub-millimeter in 3 dimensions. This is the so-called survey class or geodetic survey class, and it turns out that is the Trimble story in part, because during the time when there weren't enough satellites for 24/7, there were periods in which you could do that. You could use GPS to achieve this hyper-accurate surveying. And it turns out if you wanted to survey between 2 points that are a long ways away, it takes a whole crew. You have to cut lines through the trees. You have to do all this triangulation. You have to understand the change in height. Whereas Charlie's receivers, initially 3 hours, pretty soon it was 30 minutes, and then it was 20 minutes. Just occupy the original benchmark and where you want to find out a new point is, and you had the answer. Initially, it took a lot of software and a lot of time. Now it's virtually instantaneous. The point is, there was a market whose productivity improvements were like 90%. You could do it quicker, and you could do it without a whole lot of people. So that sustained Charlie in the mid-1980s. He had a timing business, but that was nothing compared to this business, and I think that was very important. So I'd like to now turn to a couple anecdotes. Charlie, you're going to really like these. In the 1980s, most people had never heard of GPS, and of those who had, many were skeptical. There's an American professional organization called the Institute of Navigation, ION, and they held a national meeting in Annapolis. And Charlie decided to rent a large boat and invite people to have wine and finger food and build goodwill, kind of schmooze them up. And for one of our Sunday morning meetings prior to this, we were scheming on how to put on an effective demonstration of the terrific capabilities of Trimble GPS receivers. And it turned out in my background, I'd crewed Class A racing yachts on the Chesapeake Bay, so I felt I really knew these waters. Our idea was to drop a small buoy with an anchor, cruise around for a couple of hours at night, and then return to retrieve the buoy, sort of a man overboard drill, triumphant. Here's the buoy with the little pennant on it. The first part went well. Much fanfare, and over the buoy went with the GPS coordinates dutifully recorded. We went around, fast forward, a little wine, a little cheese, and we returned to our assumed triumph. Sadly, no buoy. No problem. We executed a little search and still came up with nothing but egg on our face. I then vaguely remembered something about currents. And so there we are in the Chesapeake Bay. Here is a current chart, and you probably can't read it, but the current there is an incredibly powerful 2 to 3 knots. Now, that doesn't sound like a lot, but if you've just got a simple little anchor down there, it turns out it has no effectiveness against that kind of a current at all. So I claim that this is the way, and this is sort of my idea, so I take full blame for it. I claim that actually, Charlie, it's immortality, because somewhere in the Chesapeake there still may be a buoy floating around with a Trimble pennant on it. And so I think you can make of that story what you will. The second story was also alluded to. This is a picture of something called a trim pack, or slugger, as the military called it. And this is a wonderful advanced GPS receiver that Charlie built with the military in mind. It only received civil signals and had just 2 channels, but it was very, very tough. For example, I was going to Brazil to give some lectures, and they wanted me to precisely survey where some observatories were. So I went and asked Charlie, and he says, sure. And he pulled this out of his drawer and handed it to me. He says, here, take this down there. And then I noticed that across the top there were these black marks. And I said, Charlie, what's the black marks? He says, oh, I had a reporter in, and I bragged to him how tough this was. I said, you could run it. Charlie said, you can run a truck over it. And the reporter says, fine, let's go do it. So they went out in the parking lot, ran the truck over this thing, and sure enough, it still worked just fine. So with a war approaching in the Middle East, the military, who had been wiggling the signal, suddenly needed a bunch of receivers. They didn't have military receivers, and the civilian receivers were not going to be as accurate as they could be. So what did the military do? They turned off the selective availability at the very time that you'd think, if you're encouraging and dealing with enemies, you want to leave it on. But instead, they took it back off and ordered a bunch of receivers from Charlie. And Charlie went to work. He's a patriot, by the way. I'm not kidding about that. He is definitely a patriot. He went to work and started producing these things. And I don't know if you remember that war. It has to be one of the shortest wars ever on record. Actual combat time was 100 hours. At the 100 hours, our president decided we'd beat them up enough, and we had beaten them up really bad by going through the desert, and they weren't ready for any of that. So then, can you read that? Can you read what I just put up there? It says, read the small print. It refers to the contract that Charlie had because it had a clause in there, cancel for convenience. And what that means in government parlance is anytime they feel like it, they can just shut the whole thing down, which is effectively what happened. And Charlie was suddenly stuck with raw materials on order, work in progress, finished goods that he had no place to sell. And he emerged from that after a lot of anxiety. I think that would be a good question to ask Charlie during the talking period as to how the heck he emerged with anything from that. The last little thing I'd like to talk about reflects the fact that Charlie is a deep thinker. And that relates to a little course that I started at Stanford on managing innovation in the 1990s. And I used Trimble navigation as a role model for success, all the snares and traps that you had to run through. And the last chart that I would show in this course acknowledged Charlie's accurate perception. So this was my last chart. And I said to my students, at last a few final issues. And I said, raising dollars for a company without giving your company away, i.e. selling away control, is a big issue. Planning how you're going to exit. Are you looking for a buyout? What are you trying to do? Putting up barriers to anyone else entering, protecting your intellectual property. And then, of course, rewarding the people who are making it a success. And I took this to Charlie one Sunday morning, and we went through the whole thing. Charlie was interested. And he says, yeah, Brad, I think those are good things. But he says, you know, and here's what Charlie said, and I incorporated it into the course. Ideas are a dime a dozen. To make a business requires enormous energy, steel nerves, and that maze intelligence, the ability to run the maze you never saw before. So I put that in as my last slide with the attribution to Charlie Trimble. And of course, as I look at it, those three characteristics are a great summary of Charlie himself. And I think the result has been a wonderful success story for all of humanity. Thank you.
That's terrific, Brad. Thank you. Scott.
So thank you. And so I don't have PowerPoint charts. You know you're in a difficult crowd when people hold up paper, this way, versus that way. So the PowerPoint charts, I think, were terrific. What I'd like to do is really just make a couple of comments or observations about Charlie's impact, not just on sort of markets and technology, but actually how he affected policy and regulatory worlds. And so if you're looking at the history of Trimble navigation, or particularly the history of the commercialization of GPS, you find, of course, great technical innovation, you find great business innovation and adaptability, but also they had to overcome a number of policy issues which I think are instructive for really anybody in the commercial space business today. One of the first things I'll say in meeting Charlie, I think I've known him now for about 28 years. I was in the Commerce Department in the early first Bush administration, and we were looking at some of the first numbers for tracking what was the size of the commercial market before the Space Foundation did its reports and all that. And of course, most of the money was in things like not remote sensing, it was in things like communication satellites and fixed satellite services from geosynchronous orbit. We were starting to track some of the growth, though, of this GPS market. And the numbers were really very tiny in comparison to the rest of SATCOM kinds of things. But one of the things we noticed is that the first derivative was really amazing. It was really growing rapidly. So the compound rate was increasing in a dramatic way. So that kind of caught our attention, and we wanted to pay more attention to it. And one of the things that we learned in working with Charlie is that they had a very different perception than most other space companies did at the time, who thought of themselves as space companies. And Charlie did not. Charlie thought of himself as being in the information technology business, as being in the IT business. And this differentiated where his company was coming from versus other competitors, particularly such as Japan. Charlie, you heard mentioned the car navigation market in Japan, where most of the early Japanese producers of GPS had kind of an advantage because digital maps were more available in Japan before they were available in the US, a smaller, more compact country, well surveyed. And so the Japanese aftermarket for navigation systems was about 40% of the world. And so going after that market, of course, was a natural thing. But that also was a bit of a trap for the Japanese because they thought of it as aftermarket, as a consumer product, as a thing you sold. Where again, I think the genius on the US side was seeing this really as a form of information technology. So that slugger receiver that you saw is kind of a brick, sitting out there and you can get a number out of it. Well, that thing has now disappeared into your phone and you carry it around in your pocket all the time. Again, it's an application, it's an IT system. It wasn't thought of really as a space business. The other thing, and last thing I'll mention, is this process is continuing. The combination of GPS with high-resolution remote sensing systems spawned the larger geospatial information technology revolution. And so today we talk about terabits of data coming down from space. We combine it with geolocation information from GPS. We put it into giant data cubes, so massive that we can't even ship the data around. We instead have the cubes on various cloud farms, and we interrogate those cubes with various algorithms to understand what's going on. We've created an entirely different sort of IT space than was thought of when people were just building little boxes. The second thing that happened after this conceptualization of GPS as an IT thing was in dealing with a variety of issues. The fact that this came out of the military meant that the government originally had GPS equipment on the U.S. munitions list. And anybody who's on the U.S. munitions list knows it starts with a presumption of denial, which means you don't get to export it anywhere. Yet this was plainly being used very widely in the community and would have even more growth depending on, well, how do you deal with it? So one of the issues that came into the Commerce Department was how do we make sure we're not killed on the export control list so we can export to worldwide markets? And one of the first things I said is that there's a number of companies doing GPS. Trimble was one of about 6 or so. I go, I'm not smart enough as a government bureaucrat to know the difference between which competitive strategy you're using or not, and I don't want to figure it out. I want you to go form a trade association, figure out what a common position is, and then come back and tell me what the industry position is on something so that I, as a government bureaucrat, can react to that rather than trying to second guess what individual strategy you might be taking on. Charlie stepped up and did that with the other companies, and it's a tribute to him that the other companies, although fierce competitors, fought like dogs in the marketplaces. When it came to public policy, because of their trust in Charlie and because of the wider, and I would think not only visionary but somewhat statesman-like stance that he took, people were willing to sign on to a trade association. And those of you who are in trade associations know how important it is to have that basic sense of trust among the CEOs who are in that organization, because if it's not there, the organization is dysfunctional, simply will not work. And the GPS Industry Council was one of the most successful trade associations for a long time, in part because Charlie had that statesman-like approach and had the confidence of the other people involved. So what does that have to do with export controls? Well, they came in and said that we're moving toward these dual frequency systems. And at the time, there was a mental image that civil systems were single frequency, L1, and military systems were dual frequency. Well, of course, Charlie at the time was using the fact that the L1 and L2 signals were in phase quadrature. Those of you EE types can go look that up. And that by the existence of that fixed phase quadrature, we're able to get these high precision measurements out of it, very plainly a civil activity. So I go back to my DoD colleagues and say, well, what's your concern here? They said, well, we don't want this stuff being used on a ballistic missile. We don't want it being used in supersonic aircraft, missile tech control regime and all that. And I said, okay, that's very sensible. So how about, what can we do to limit it from being used in these devices? And they go, well, we don't know. We just don't want them used in missiles and high-speed aircraft and above certain altitudes. And so I go back to the industry, and they tell me, well, that's easy. We can just make sure that the chips don't function above a certain speed and a certain altitude limit. We'll just have it cut out. And you can burn that into the ASIC chip and make sure it doesn't happen. I go, oh, that's brilliant, great. And when you talk to your production line, how long is that going to take? I don't know, we're doing another order pretty soon, I don't know, 6 weeks. And so I go back to the interagency and say, how about if we put speed and altitude limitations so that they're absolutely incapable of operating above restricted altitude and speed limits? And they said, well, that'd be great. How soon? I said, well, about 6 months. And of course, the industry, kind of beat that number. And so basically that, if you look at the export controls today, they are very, very specific. They don't talk about single frequency and dual frequency. They talk about, are you capable of being integrated on a nuclear weapons platform? Does it have cryptographic data in it? Is it something that can operate above a speed and altitude limitation that would be problematic for MTCR purposes? And if the answer is no, well, then it's a general destination item that can go worldwide. If it is, it's going to be controlled. And that control has been very, very stable. The reason it came out, that way was in part because of the dialogue and the adaptability that the GPS Industry Council was able to bring to that. You've already seen the selective availability number, turning to 0. I would also say that this was a time when the existence of selective availability out there was not only something that was kind of useless because people were already working around it, but also in many ways was dangerous, in that people in parts of the DoD were thinking, well, we have selective availability and therefore no one's going to get more accuracy than us, when in fact people were getting much more accuracy. And as a result, the military was in fact not investing in navigation warfare techniques for jamming of GPS in a conflict area without hitting other areas. They were not investing in ways of operating under a challenged or a jamming environment. So not only was it kind of useless, it was actually becoming actively harmful. So one of the things that the Clinton administration did prior to the 2000 turning of SA to 0 was to create the first policy on GPS, which was the 1996 policy, and which said, we should invest more in navigation warfare systems. We should invest more in operating in these kind of challenged environments. Now, at the time, I was an analyst for the RAND Corporation, and I thought GPS was a great subject, having spent time on it in commerce. And I couldn't get anybody's attention. Like, nobody really said, GPS, that's nice. Why do you care, Scott? Well, look, it's showing up all these places. The air traffic guys are talking about it. The missile tech proliferation people are worried about it. It's showing up in the numbers that we're seeing and what the commercial market was. And it's a classic cross-cutting policy issue that was popping up independently in all these different areas. I mean, that to me just cries out, you know, we should probably try to corral that and put together a policy approach on it. Nobody could care. So the immediate people in OSTP cared, but you needed higher level than that. And so it turns out there was a flood, I think in Louisiana, down the south sometime, and President Clinton went down to inspect the flood damage and what was going on. And at the time, the National Guard was using GPS to mark where they would drop supplies, and they would go and service various areas, pre-position supplies, drop them, and service them, and so forth. And the president, who talked to his vice president, Al Gore, from time to time, leans over and says, oh, so you're using GPS? And of course, the guardsman brightly pops up, oh, yes, sir, let me show you what we're doing with GPS, and isn't this great? Okay, fine. So then later, the following week, literally I'm outside a restroom in the old executive office building, and the young staffer for the president, who couldn't give me the time of day beforehand, grabs me by the arm and says, the president knows about GPS. I'm going, well, I would hope so. He seems reasonably well informed. This is important. We need to talk about it. Oh, now you care. Okay, good. So part of things are finding a policy window. You know, you can have a great idea, but finding that window of opportunity and do a lot of preparatory work beforehand. And so, and actually in doing that review went, I think, reasonably smoothly, in part because there already had been a lot of conversations over these economic issues, security issues, and diplomatic issues. Mentioned the spectrum conflict in 1997. So the policy on GPS was signed in 96. There is not a word in there about protecting spectrum because nobody really thought that that in fact was a risk. Yet the very next year, essentially the United States was attacked by its allies. This was at a time in the late 1990s, dot-com boom, internet was flush, low Earth orbit mobile communication systems, Iridium, Globalstar, Teledesic, and so forth were all out there. And Inmarsat wanted to get in on this game too, but they needed to have a 4 megahertz downlink to pair with their 4 megahertz uplink they already had, and they thought sharing in the lower half of the GPS band would be a grand idea. And as Charlie mentioned, that advanced quite considerably in 97, and we really, by the skin of our teeth, were able to stop that. 3-year campaign, both partnership between government and industry afterwards. The whole story about that particular fight is a whole nother lecture I won't go into. But by the time we get to 2000, when we land in Istanbul for the World Radio Conference at that time, we had enough votes to lock this up but it took about 3 years to get to that point. It also turned out the intervening years, dot-com bust had happened, people weren't interested in LEO communication systems anymore, and Europe was interested in having its own satellite navigation system called Galileo, and which in case then, so the international allocations for that spectrum have been relatively untouched since. Still a number of challenges, again, another lecture, but the fact is we came to an international consensus as a result of that. But again, the industry and government teamwork necessary to fight that internationally would not have been possible without Charlie's leadership, without the trust the other industries placed in them, without the trust that government people placed in this and why this was important for national interest. And then finally, looking at business about the Gulf War, the production lines that Charlie turned over really all of his production lines to producing to serve the immediate needs out in the Gulf. There were some other stories. I remember at the time that pretty much every Fry's electronics store in Silicon Valley was robbed of batteries to then go into the GPS gear. We had C-130s landing at Moffett Field outside of Ames. They would load up and then head out to the Gulf to make sure the equipment got into the hands of the pilots who needed them. In the aftermath of the war, conversation I was having with a friend of mine who was talking to an Iraqi general officer, very well educated, professional soldier, mostly Soviet educated, and who expressed, of course, surprise at the left hook coming out of the desert. And his phrase, we don't go out there, the Bedouins don't go out there. So the fact that you could have a large armored unit operate that way was quite a surprise. And he was shown a copy of one of Charlie's sluggers, and again, educated man, understood what it could do, understood basically how it worked, and said, okay, this makes sense. So every one of your corps commanders had this device. And the interviewer laughs and goes, every one of my platoon sergeants had one of these. And that's where you could see the scales drop from the eyes, because the level of industrial power and innovation and ingenuity necessary, not only on the industry side, but on the military side, to incorporate that high technology, you could have airdropped sluggers onto the Republican Guards, and they really wouldn't have been able to use it. The fact is that U.S. Armed Forces, based upon the IT technologies that they had trained and operated with and the capability of American industry, on the basis of policy, regulatory, and international decisions over the previous decade, of which Charlie was central, was what made that astonishment possible, and which still needs to be done to face the challenges we're heading into right now. So with that, I look forward to the conversation.
Scott, thank you. That's terrific. Well, we've got about half our time remaining, and I'd like to use it in a discussion format and to take some questions from the audience. But before we do that, let me maybe ask a couple of questions to starting with Charlie. And we've received this one in various forms from many of you as well. And Charlie, what's ahead? It's hard to predict given market changes, technological advancements, and just the serendipitous nature of any business. What the future holds. But if anybody could give us a pretty good roadmap to satellite-based navigation 10, 20 years from now, you probably could. So let me ask, what do you think's ahead for us in this terrific market area?
Well, what the satellites are going to be doing 10 years from now, in many ways are very similar to what they're doing now, and that is providing this global grid to which other things can be attached. It's the knowledge of space-time, which is the utility. And GPS provides you with ground truth for achieving that. But if what you want to do is know where the buried electrical wires are inside of a building, you're going to have to have virtual reality and vision systems that are associated and tied into this grid. The amount of data that is being produced is amazingly large. You're going to be integrating AI into the solutions that you're making. And fundamentally, you look at the smartphone today. That's position, connectivity, and connectivity is not only talking, but internet and IT. It's computational power, and so it's your personal portal to the digital world, and those things are just simply going to get better, and virtual reality and artificial intelligence are going to be added in.
Yeah, Brad.
I agree with Charlie's remarks. I'd like to add something. The FAA tends to look at systems, positioning systems, in terms of their accuracy, their availability, and their integrity. And most civil users tend to focus on accuracy and availability, i.e., is it here? Do I have? How much accuracy do I have? I contend the next thing that has to be addressed with greater vigor is integrity. That is the assurance that when it says something, that's exactly what I'm getting. And the reason I say that is I see markets opening up now in terms of the auto steering, the automatic steering and control of vehicles like cars on busy roads or trucks. The semi-industry has enormous need for additional drivers. There are ways right now that we can get around that, but the only way that GPS can really be utilized, and not just GPS, but position, navigation, and time, is we need to have assured integrity. And for the landing of an airplane, you need to have integrity such that not one time in 100 million does it give you a lie. I contend you need that same level of integrity if you're going to use it for the automatic control of cars and trucks on a roadway. And there are other examples, but to me that's an interesting one. But again, it reflects that this third leg of the FAA's way of looking at this has got to be emphasized. And we've got additional constellations from other countries that we're going to have to use in order to build up that integrity and confidence that the signal we got is right.
Terrific. Well, maybe following up a little bit on that last point, but expanding it a bit, starting, if I could again, Charlie, with you, what should we worry about? What are the threats or the vulnerabilities that could darken the picture over the next decade or two?
Very simply, spectrum and noise floor. The hottest political battles and probably the most valuable thing that we have is radio frequency spectrum and the competition for it. And
I agree.
That's it.
Yes, Scott.
So building on that, the experience that occurred in the late 1990s after the Iridium and Globalstar busts, I think led some regulators to think that satellites really aren't terribly useful, that the real money is going to be on the ground, 4G, and of course now 5G. And I think if you look at that, however, Charlie's point about the spectrum, noise floor being really important, the things that really make money in commercial space are satellite services, various kinds. And that's what we launch, that's what we use. Tourism will occur, but right now the real money is in this. And so making sure that that spectrum environment is regulated in such a way that enables not just regular communication satellites, but remote sensing systems, enables satellite navigation systems, all to kind of work together and not interfere with each other is really crucial. And I think one of the risks that we have is because so much money is flowing into the 5G and terrestrial areas, that relatively speaking, people tend to say, well, those space things are relatively minor, when in fact for national security, public safety, scientific purposes, they're actually really quite important. So one of the things that we've been talking about, as an administration and with others, is the importance of a mixed strategy in the approach, that space is a part of the terrestrial services. So when we had that fight in 1997 with Inmarsat and mobile satellite services, it wasn't because we thought mobile satellite services was a bad thing. In fact, GPS and MSS were quite complementary to each other in separate bands. Shared, not so much, but separate, they were, in the market rates, actually quite complementary and useful to each other. And so finding those areas of complementarity, of trying to make sure that we don't let our fixation on, say, which one aspect, however lucrative, to lose sight of the larger public policy balance we want to maintain. I think that's the challenge that SatNav is still going to have in the future.
Great. Well, maybe picking up on that and going to a couple of the questions that we've received from the audience. One of the questions asks whether or not in the future positioning, navigation, timing, signals from satellites could be expected to use radio frequencies other than L-band, either because there were advantages from a accuracy, availability, integrity standpoint, or because they may be pushed to narrower and narrower spectrum. Any thoughts on that?
All right, two thoughts. One, there's a general tendency to believe that if you've got a space-based system, you ought to be solving the problems from space. When the fact of the matter is, any problems that you can solve on the ground, it's far better to solve them on the ground, because by the time the space technology is up there, it's 10 years, maybe 15 years into its lifetime, and what we do on the ground can be iterated in 18 to 30 months. So the innovation, the rapid innovation can be done on the ground. Yes, it would be possible to be using other frequencies. Part of the problem, though, is that if you used other frequencies, you could not grandfather the billions of users that are already using it. And as a matter of fact, one of our key strategy in driving the price of GPS to zero was to make the use so ubiquitous that no one could screw around with it. And you know, we're almost there. Certainly, the fight is always going to be, you know, for the needs of communication. Because if you generate a hierarchy of needs for humans, communication comes before knowledge imposition. But a lot of the advances that we're having and we're moving forward with is really the fusion of those two fundamental capabilities, and that has to be maintained.
Yeah, Brad.
I agree with what Charlie has just said. It seems to me that the L band, it turns out the L band is the right place to be for ranging signals, because if you go lower in frequency, the ionosphere destroys your accuracy, and if you go higher, the antenna gets so small you don't have enough power. That said, it seems to me that the current allocation has got to be grandfathered in indefinitely. But on the other hand, as we get more skilled at our antenna technology and can go to beam steering antennas, we can do what the Europeans are apparently doing. They have an allocation already for navigation that I think is in the S or C band. Do you remember?
C band.
C band. And the point is that, yes, you get less power in an omnidirectional antenna, but as the technology in antennas improves, not only can I do beam steering and eliminate spurious transmitters or jammers that are nearby, I can also get that improved accuracy if I can receive the signal with adequate power. And you can't probably do that with just a single antenna, but with an array of antennas, for the user who can afford it, that might make a lot of sense.
Terrific. And Scott, yeah.
So in addition to the antenna characteristics that make L-band physically probably the right place to be in the installed base argument, another argument that sometimes comes up is, well, we have millions of more users who could use that spectrum more efficiently for a different use, for communications, for example. And so you guys need to go someplace else. And I think that that's actually would be a very dangerous argument for someone to make, because the reality is the nature of radio navigation and satellite services today is we can serve an infinite number of users with the same spectrum. There is no spectrum that is more efficient than the L-band spectrum that GPS uses. Basically, you can serve an infinite number of people, as opposed to, say, a communications system that has a two-way aspect to it. And in fact, one of the policy arguments about, well, why don't we charge user fees for this, put on the professor hat for a moment and have people recall that the phrase price should equal marginal cost, and that's an optimal setting. And the marginal cost of an additional user of L-band spectrum, whether by Galileo or GPS or GLONASS or Beidou or whatever, the cost of that marginal user is zero. And in fact, the socially optimal point is to set the price equal to zero. Whereas other kinds of systems that have a cap on the number of users, like communications, the price should not be zero. But in GPS's case and other GNSS systems, it's already optimal.
Terrific.
Yep.
I have a long list of questions that have been submitted electronically, and I'll tackle one of those now. But I also want to give those in the audience that would like to ask a live question a chance to do so. So be thinking about that. I'll have one more question here, and then we've got a microphone set up right here in the middle of the room for someone that would like to talk to Charlie, Brad, and Scott directly. A lot of good questions here. Several questions come at this matter from a little different set of perspectives, but basically the question, the thrust of the question is, well, what about these other global or regional systems now? We've got Galileo in Europe, we've got GLONASS, which we've had for quite a while in Russia, the Chinese have a system. The Japanese and the Indians are deploying systems. What are some of the opportunities? What are some of the difficulties that we can expect as we move from one dominant global satellite navigation system to multiple global and some additional regional networks?
Well, I would maintain that from the civil side of things, there's basically no downside and everything is upside, because fundamentally these national and regional systems that are being put up to compete, frankly, with the military aspect of the GPS system. We are getting, I shamelessly abuse the signal structure that Brad put into the GPS satellites, and we can do absolutely the same thing to all of these other national systems. And so there is no reason in the world, and as a matter of fact, there are products now that basically can accept signals from any of the systems and use them fundamentally interchangeably. And instead of having 24, 33, whatever the number of satellites we have up there right now, we have in the 70s of ranging signals. And so the availability has been drastically increased. You do not have to, everybody thinks that you have to get all of these systems to work on the same standards. Frankly, the computational power that we have basically allows us to take whatever is there, sort of like Salesforce and using databases. It's not an issue, it's a positive.
Mm-hmm.
I totally agree with what Charlie's saying, and I co-chair, as you probably know, the National PNT Advisory Council. And one of the thrusts that we have had is that the United States citizens should have complete open access to all of the navigation systems. There is a fly in the ointment. The FCC, in their great wisdom, has not allowed, technically, a GPS-type user to listen to the others. Now, they can't prevent it.
Yeah, we do it anyway.
They do it anyway. As a matter of fact, as I understand, the latest Qualcomm chip actually can listen to all of them, all four of the constellations. And I think the group that is most benefited is someone called the United States citizen.
Right.
And so we on the Advisory Council have been strongly encouraging the use of all signals, free and open, and have the SEC go ahead and authorize that as just a reasonable thing for the United States citizenry. There is a catch here in that the FCC has not authorized them, but the FAA, for their regional correction system, is building the monitor systems that'll use them. Is that an irony? What is that? I don't know what that is. Thank you.
Very good.
So one of the things I would point out in this, well, generally, the feeling is, more is better, and you can, through the wonders of Kalman filtering, you can combine almost anything together. There's a cautionary history here, though, in what happened with the Russians in the 90s with GLONASS. There were GPS GLONASS combined receivers for a time in the marketplace, because in theory the combination would be better even with the lesser computing power back then. And it didn't work. And it didn't work because the GLONASS system would be unhealthy and wouldn't necessarily say it was unhealthy. It didn't have integrity. And as a result, people found that using GLONASS, while theoretically an advantage, was in actual practice a negative. And it gave you worse results than if you just did GPS by itself. And so the challenge for many of these new entrants, and I think they'll probably make it, but the challenge for the new entrants is that GPS has already established a level of operational excellence and expectations. So the new entrants coming in, if their signals are actually going to be used, need to show that they can have that kind of integrity, they can have that kind of accuracy, because GPS GLONASS devices basically left the marketplace in the 90s and trying to claw that back. A second part of that is that people keep thinking that there's money to be made by having a GPS constellation, and that's actually not true. Money is to be made by having the equipment on the ground and the applications and everything else. It's like many other kinds of infrastructure. It's like owning airline stocks. No one really makes money in airline stocks going back to 1903. Okay, having an airline system is really important for the economy, but running a transportation network, so whether it's trains or airlines or an infrastructure like GPS justifies itself on the military benefits alone. Absolutely by itself, it meets the public good. The fact that we then make that signal available for free is then another larger bonus on top of that. Other countries don't necessarily face the same policy requirements. So if you're Russia or China or Europe, you want to have your own GNSS system as a point of national pride, sovereignty, independence, or whatever. But one shouldn't confuse that with actually making money, which is, in the applications and it's on the ground, not in space.
One of our arguments to the U.S. military, one of the pushbacks that we were getting from the U.S. military on user fees is that as civilians, we weren't paying our fair share. The military was footing the bill, and they were also having to put up with dealing with us. And so their argument was that we should be paying. And actually, I can remember reviewing a slide deck for a presentation on a Schlesinger panel, I think it was a NAS panel, that basically was arguing the user fee issue. And our point fundamentally was, look, by making GPS free and the standard of the world, we're denying the French and the Chinese from subsidizing their own military systems from civilian users, and it's really hard to compete with a free utility. And as a matter of fact, I think I can credit Scott with the slide that still sticks in my mind that was used in this presentation, and it's this poor bloke with a gun pointed to his head, and it says, when you have a gun to your head, whose finger do you want on the trigger? And this was there because we were telling the military, look, you can screw up civil GPS anytime you want. If we have made GPS a standard in the world, you are giving up absolutely nothing to be in any theater of operation, but you're not going to be in the theaters of operation very often or very many times, so everybody's better off. It worked.
Great.
It took 3 times. We had to fight this user fee battle 3 times. And by the way, it was not a particular advantage to Trimble because our money was made by that point in time on differential systems, and selective availability didn't matter. The user fees were going to have to be, at the marine and civil aviation levels, and so high value stuff wasn't going to be impacted all that much.
Okay, let's open it up to some live questions from the audience. Would anybody like to ask Charlie, Brad, or Scott a question or make a comment?
curious, one of those stories talked about having created another competitor, sort of by conflict inside the company, but not much was said about that. Is there any more to enlighten us about that?
All right. Actually, Javad Asjay had a lot to do. He's a brilliant software engineer. And he had a lot to do with almost getting to the point that this differential carrier phase stuff worked. And there was a bug. And he was really proud, and I mean, after the bank had pulled our lines of credit and asked for their money back, and I mean, we were looking at death's door. I had to force other people to also be working on this problem, and Javad was convinced that if he didn't find the solution, somebody else would get credit for this, and the somebody was Ralph Eschenbach. So I picked the most brilliant, egoless person in the company, a fellow by the name of Timo Allison, to work with Javad. And, you know, the 4 satellites at that point in time were up during the night, so Javad would work during the night, and he wouldn't really talk to Timo. I mean, he would tolerate Timo being there and looking at the code, but he wouldn't really talk to him. And Timo started noticing that while the source code wasn't changing, the object code was. And I can remember early one morning, Tom Coates storming into my office and saying, "Damn it, Javad is playing with the code. It's either him or me." And I actually got Val Denninger, who worked for Brad in the JPO. In fact, he was the guy that basically got everything that we did with the military underway. Anyway, he ran the investigation, and he came back and said, "Yeah, it is Javad." And so we fired him. And he went off and formed his own company and competed with us. The silver lining was that in those early days, actually having a competitor was an advantage, because everybody's second choice is do nothing. And if you don't have a competitor, you're competing against doing nothing. So actually, it's easier to compete against a competitor than doing nothing.
Terrific, terrific. I think you get a sense, just listening to Charlie and Brad and Scott, how challenging it is to create a company and grow it and deal with all the ups and downs that all growing enterprises at some point experience, and certainly in this area with some of the special technological challenges and public policy crosswinds. It's even more remarkable to me to consider what Charlie and his team have created. We have another question. I think that looks like Jim.
Jim Armour.
Yeah.
Congratulations, Charlie, on this recognition, well-deserved recognition. I was the multiple successor to Brad Parkinson. I was the JPO director from 97 to 99, 2000, and I have enjoyed these reminiscences of the stories that we've had. There were several others ongoing too. During the 96 to 99 timeframe, we were also developing the M code, the enhanced signal for military use, and spot beams, so that there was differential power that could be used for that. My question more is in the commercial business. Are we seeing much spoofing or other than just simple jamming or interference. Are we seeing that at all in the commercial business? I know the differential systems are inherently resistant to that, but I just was curious about where the commercial industry was going towards the integrity comment that Brad talked about.
It's actually too bad that Bren couldn't be here, because part of the reason he's here because of a family health problem, but I wanted him here because he had transitioned from, I left Trimble basically in 98, 99. And so I've actually been out of the GPS world for almost 2 decades now. And so I don't know. I know the backstory. I actually was asked what I wanted on, in terms of new signal structures on the Block 3 satellites, and by Bill Perry's deputy. And my answer was, I wanted him to use his money to maximize military equity, because we would be able to figure out how to use the signals to make things work for the civil market. And so I know that there were a bunch of consultants that were really pushing a bunch of different aspects for improvements to put on the satellites. I never thought that they were terribly important.
Spoofing, of course, has been spectacularly demonstrated by a few professors.
It's
and
easy.
It is, and it can be done. It would not be the go-to technique for the average person. And part it's because the average person who is hostile to GPS use. And in part that's because if you're spoofing someone, you're not certain you're spoofing him or not. You're not certain if it's working. The preferred technique is to jam, because if I put in an overpowering jammer, I'm pretty assured that it's going to work. The other part of that is that a GPS receiver, a really good GPS receiver, should rarely, if ever, be spoofed. And the reason is, even if it can't measure position accuracy to millimeters or centimeters, it can measure velocity to a phenomenal degree of accuracy, and it's rarely used. But it turns out, generally, a user has a sense as to whether he's heading north or east or west or whatever. And that's a simple example of the kind of cross-checks that a really intelligent GPS receiver should have. I know that spoofing is a very fashionable attribute to worry about. Frankly, I worry a lot more about frequency allocation in the FCC than I do about jamming and spoofing. And my second is jamming, and then at the end of that comes spoofing. And the reason is, we already, as engineers, as developers and manufacturers, know a heck of a lot more about how to defeat a spoofer than we do about some of the other things that the FCC could foist on us.
Yeah, Scott.
I would say another aspect of this on that list of things to worry about, I agree with spoofing being lower down on the list. One of the things to worry about back in the spectrum allocation is actually the number of other GNSS systems, both regional and global, that are around there, because they're all overlaying each other in the same L1, L2 bands and L5 bands. And if there's about 4 of them, it's kind of not really a problem. So GPS, Galileo, GLONASS, BETO is fine. But as you start laying in, say, regional systems of various kinds, of course we have the QZSS, the UK is talking about their own another system, South Korea has talked about another system. What happens is the noise floor starts to build up. Now if you're an aircraft, you can go pick out the most highest power signals and you're fine. But if you're a terrestrial user and that noise floor is rising, it's not so easy. So actually international cooperation and coordination to the point where we have not only interoperability, but maybe we husband the use of these L bands so that the noise floor is relatively controlled, not only from outside sources, but from GNSS systems themselves, so that there isn't an infinite proliferation of these things. Now, I think that's possible in part because, again, the real money is on the ground, and if there's enough confidence that with multiple independent systems that people don't feel they're going to get cut off, I think you might be able to get there. But there is an issue, I think, of overuse of that band. The other, related to that, going back to modifying the signals and structures and somehow being better or improved, the Europeans have kind of gone down this path fairly intensely, trying to find ways to make a signal structure that they can argue is better than GPS, and then potentially provide a way of recovering user fees, either direct or indirect, from use of this, quote, improved signal structure. Their general technique had been to offer other kinds of services rather than the signal structure itself. And this meant having to be creative in the space segment as opposed to being creative in the ground segment. The GPS, to my mind, to stretch a bad analogy, it's kind of like a free Linux system that already has 99% market share. And then you want to introduce Windows Vista into that and get people to pay for it. You know, you can make an argument that Windows Vista has all this cool stuff in it, but getting somebody to pay for that over simply putting the solutions into your equipment, I think is a very, very hard road to go in. I mean, the nature of this GPS's infrastructure is keeping the signal really simple and really basic and putting that innovation on the ground. I think so far has proven to be, you know, the right way to go. So those are the two adds I would make.
Great. Here's another question that reminds me of a little bit of the history of maybe pre-GPS and early GPS that you were leading, Brad, some years back. I think probably 12 or 15 years ago. Bill Ballhouse, who at the time was running Aerospace Corporation, gave a talk that I was very impressed by that was entitled "A Day Without GPS." So maybe tell us, Charlie, Brad, Scott, what would a day without GPS look like to modern America?
We've experienced that a little bit. There have been some cases of inadvertent jamming. And when it does, you see cell phone towers, which are flywheeling time, slowly lose track of time. You see, obviously, users, taxi cabs, you name it, suddenly out. But there's all kinds of subtle things. The surveyor no longer can use his very accurate survey. You say, so what? Well, we also use that for monitoring earthquake faults. All of that goes away. There's some 10 major classes of GPS users. And if you talk about just the GPS or GNSS, as we call it, no longer being there, every one of those is gone. And the impact, according to the study that was done, is you lose some of the close to $70 billion of benefits, but you also lose things that were not quantified. These are $70 billion per year. You lose some of the things that are not quantified, such as safety of life. Some of the things that would be contentious were not even in that equation. The emergency provider getting to the heart attack victim on time. You lose all of that. I don't know, Charlie and Scott, you may want to add to that.
Hey, my almost in jest comment is if GPS wasn't there, arguments between couples while driving would increase vastly.
So prior to GPS, I had a friend of mine who got married very happily, and I said, well, what was it like before you got married? And his comment was, I got lost a lot. And so now maybe GPS.
Yeah.
One of the things on a more serious note, I would say, and this goes back to not just GPS, but really a whole series of technical innovations in space and time that have been done in the information revolution. If you want to think about what warfare looks like without space, without GPS and other space systems, and without nuclear weapons, let's posit, it looks like World War II. Okay, and so a level of collateral damage, mass destruction that no one would ever want to ever revisit, again. So for whatever issues people have with modern warfare sort of today and the evils and damage that it generates. If you think about what it looks like without space, you see World War II. And no one wants to sort of revisit that for whatever differences we have. So space is integrally necessary to our security, and GPS is a foundation of that, because to go back to a pre-space era is I think a level of horror that we would do almost anything to avoid.
We just have a couple of minutes left, and I'd like to bring this back to Charlie. Maybe I can generalize a couple of the questions that I received electronically, Charlie. And basically, they say, looking back with the full benefits of 2020 hindsight, given everything you know now, what would you say is the single or a couple of the very best decisions you made, and maybe something you might have done differently?
All right. Let me take the second part of that first. I wouldn't have been sucked into the competition with Rockwell Collins for the winner-take-all on Plugger. We were absolutely stomped. Rockwell, we had to design a completely new receiver for this application, and because they changed the specs, right? And they bought the contract. They bought it at 38% of our factory cost. But in any event, I wouldn't have done that. And what I know now is that companies in the civil environment and companies in basically the government contracting environments don't compete well in the other's turf. I was able to beat Rockwell in every market for GPS other than the U.S. military. But I got stomped. What was best? Actually, the feeling of satisfaction of doing something that actually saved an awful lot of American lives in the first Gulf War. We lost money on that, and we had all sorts of problems in the end. But we did have 4,500 units or so in the field at the time that the sweep through Iraq started, and actually the positive that came out of that, and actually the positive that came out of being stomped by Rockwell, was that I had access to the top people in the Pentagon and in the civilian leadership for the decade of the 90s, and it was absolutely crucial to have the top-level military support. I gave you the one example there. Another example is it was an assistant secretary of defense that corrected a clerical error in an FCC ruling that let us survive an incredibly contentious battle, which we had lost.
Well, thank you all so much. Unfortunately we've run out of time. We could have gone all afternoon, I'm sure. Please join me in thanking Scott, Brad, and especially Charlie for sharing their experiences and their knowledge with us as together they've created this fantastic business centered around satellite-based services. Guys, thank you.
I wouldn't be here. I would not be here if it really weren't for these two guys.
Okay. Great.